This is the final video on the TCP server device core that allows various types of integration from TCP clients that you write, either in software or hardware, that would integrate with Reactor, being able to set values in a shared memory. So what we have seen in previous videos, because this is the third one, is that we have integers, option list, booleans, we even have strings, we have a string matrix, we can upload icons, and you can do that from clients. In this case, I give examples of how to set a PNG image. And from one connected client, I have two connected clients in this case. This is the other connected client. And if I type in list, I can see I get a report of all the variables or the values inside the device core, and I'm able to actually change them from here. So as an example of changing a value, I think this number is actually integer number 10. So I could just type in integer number 10 and then change the value to 111, and then it gets updated here. And if I press this button, you'll see that I'm also changing the value in the other direction. So it's a two-way communication of values, shared value space for all these types of things. And now it could be fun to try to connect that to virtual triggers, because so far I've put them onto a display so that you can change them with a button or you can show them in a display, and that's one way of using it. I also believe that it could be quite interesting for many of you to take these values, use them as a way to execute actions on devices. So that's what we'll focus on in this video, and we'll go to the Home tab, where we do not have any more devices than the TCP server added. But I'll search my network for devices. So we see there are quite a few, and it's the Casper's ATEM Mini that I'm interested in here, which is of course my go-to item for ATEM changes. So we have this ATEM switcher. Let's see if we have ATEM software control up and running here. So that's going to be useful as well, having it as a way for us to check how the ATEM switcher is reacting to what we are going to do next. In the configuration mode, we have been working in section view, where we have created a few pages. This is our background page of the frame shot, which was our choice of controller for the demo. And this is a string label page that I created. But basically, when we create virtual triggers, we don't care about the sections. We would typically go to the root layer. And on this root layer, where we have previously created a master behavior, we will now create some virtual triggers. Yes, and the first one would be cut. So we'll do a cut virtual trigger on the ATEM. And let's edit this one now that we created it. We can give it a description if we want. We want it to be in binary mode, and this explains a little bit what it means. And basically what we need to do is to listen to the state of something in our TCP server device core. So as an example, if we type in help here, we see we have different registers we can set. It could be a flag like an good old Unisketch that we would be listening to, or it could be, there's also a boolean here with a larger capacity. Let's try the old Unisketch thing. So for instance, we could type in flag number 10 equals 1. And then you see that flag number 10 is now 1. And if we list all the values we have, you'll see that in the list of flag values there, flag number 10 is actually 1 right there. So what I want to do is to say, okay, if in my TCP server device call, let's type in flag, if flag register number 10, yes, okay. So when that is equal to true, because this is a binary value, if that happens, I want something else to happen. So I'll go down here, create a new behavior, and then I would pick, let me see, if we pick other here, we should be able to make a trigger action. So I want to trigger an action on cut on the ATEM switcher, okay? So I will then go to the ATEM switcher, type in cut, I think scroll down to the bottom where we have the transition for cut on ME row number 1. Okay, so basically, as this value flag number 10 is changing, we should be able to see a cut happening on the ATEM switcher. So let's see if that is going to work. Okay, so I just have this window open here. Then we first we set it to 0, and then we set it to 1. Are you ready? We see the cut happening because it is basically saying it is on the transition from being, now it's false, but it is on the transition from false to true. When it is true, that this cut is going to happen. Now, the disadvantage, so we basically have it working. We can send a cut to the ATEM switcher through Reactor using this flag number 10 that we have decided to use for this particular purpose. But there's a smarter way inside the TCP server device core to be used, and that is called timers, because a timer is something that changes its value for a short part of time. Right now, the issue is that if you send flag number 10 equals 1 multiple times, it won't work. You need to reset it to 0. But if you do it with the timer, let's say we take timer number 10, and we set timer number 10 to, you set it to a value in milliseconds. That's actually described right here. Set refresh timer for so and so many milliseconds. So notice what happens. Timer number 10 is 1 for 500 milliseconds. That's half a second. And then it becomes 0 again. So this is actually much smarter, because then if we just go back here, we would then change this parameter over here to say, instead of flag register, we'll use timer. Time trigger, and we type in a timeout of 500. This is just to give enough time. So it could be 100, it could be 2 minutes. But if you choose 2 minutes, it means that you couldn't send that trigger at a higher frequency than 2 minutes. So you would choose something like 500 or 100 milliseconds. But it has to be enough for the whole thing to be picked up. And probably under 100 milliseconds is a bad idea, because I think we evaluate virtual triggers with like 10 hertz. So that's 10 times a second. So choose 200 or 500. That's going to be easily enough. Now, let's pick the timer. We chose timer number 10. Yes, and it's still true we're looking for. But now automatically it goes back. And it means as we are typing in, we can basically repeat this guy. I was just pasted in now. I copied it and I pasted in. You see it makes a cut on the ATEM switcher. Let's try it again. Cut, cut, cut. Cut. That's pretty cool. What happens if I put in 5,000 and then I put it in once again? But nothing is happening because, yeah, okay. Let's put in 5,000 like this. Then I put in 5,000 again. It's not going to cut because it is still true. And every time I do this, I'm refreshing the timer, so it's never going to be false for as long as I do this within 5 seconds. But you see, after 5 seconds, it goes back to 0, and then as I just paste this one in again, it will make another cut. Okay, that's great. So much for cutting. Now I want to show you something else we could do. Maybe use an integer to control volume in an ATEM switcher. That would be another great example. So we create a new one, volume control. Yes, and we open this one up. We select the analog type. It's enabled. That's all great. The IO reference we want to use would be from our TCP server device core. We type in integer to pick an integer value. Let's pick integer value number 60. 60. It's just what, I mean, you need to keep track of that yourself. So it's now taking this integer and using that to create a mapping to the volume button. Yeah, and we need to do something to make that work. And I'll show you. Let's just quickly do this. Because in the previous video, I've shown you how you can define a range for an integer. First of all, integer number 60. We set it to, let's drive it in a range between, oh wait, we had the did I introduce test tube in this video? Otherwise, test tube is a window into the values that is inside a device core. So I'm currently inspecting the SKAARHOJ TCP server device core. And if I go into the integers and I look at the integer value for number 60, I'm pretty sure that it is pretty boring and it says invalid. But we could now type a value like 10. Notice what happens down here. It actually outputs integer 60 is 10. And if I change the value of it, then you see it also updates down here. But unfortunately, the whole range of this integer is from -2 billion to +2 billion, which is an signed 32-bit integer, and that is a little bit too much of a range for volume control. So what if we do integer range number 60, and then we basically define that I want to drive the volume with a range between 0 and 10. And somehow it did not accept that. Did I do something wrong here? Int range 60 0:10. I don't get it. I'll just try it once again. Yeah, that happened correctly. Now, unfortunately, it shows up in a bad way here. I don't get it, but okay, let's do something else then. This is a bug in my test tube, which is a test tool. But let's say that we want to drive the value, the volume of the ATEM switcher with the value range from 5 to 15. 5 to 15, where 5 is 0, 15 is the max value. Okay, so at least now you can see test tube responds correctly. It actually picks up that my range is 5 to 15. Perfect. I'll now go back into this place here. And oh, there's one thing that I need to do, and that is every time you use this analog trigger inside or analog type of virtual triggers, you would basically want to use current normalized, because what that means is that it's going to take this value range from 5 to 15 and convert it into a range from 0 to 1000. This is how virtual triggers work, because they kind of simulate a fader, like a physical fader that we are now going to associate with master volume. So having done this, and I think full range changes is it something else? Let me see, other, let's try other audio meter. I was looking for something like fader. Okay, fader action. So basically we have simulated fader action from the value from 5 to 15. That simulated fader action is now being used to drive the master volume of audio from the, let me see, master volume position. Yeah, this sounds great for that one. Okay, so let's see if this works. Let's pull up the ATEM switcher software here, and then we go to audio. So we have the master volume over here. Okay, and this is the value that we hope to drive. We could do it from the UI here, so we should be able to basically see how the volume is changed. As I'm changing this value, now I'm using the test tube. You see that it goes in steps, but this is because I defined to have exactly 11 steps, 0 and 10 in 5 and 15 included. So I have these 11 steps that drives the volume. But of course, the point is not using test tube. This is just because that was the easy choice for me in this case. Let me just pick this one so that I can show you that if I have this terminal open, as I type in int number 60 equals 10, then it's probably going to position this in the middle. And that is what this virtual trigger does. Now, if you change the range, yeah, actually we could do that pretty easy. So let's change the range, integer range number 60. Let's change it from 100 to 200. So as I'm doing that, it means that now if I type in integer 60 equals 150, it's going to put itself in the middle. And now I have a range, a resolution of 100 instead of 11, or 101 instead of 11 as I had before. And you can also see it's reflected inside of test tube. So actually I have more smooth operation of it. Hey, it's up to you. It's just you who in this way define the integer range, and by normalizing it to simulating a fader input action from 0 to 1000, it can adjust any value that you can associate with a hardware component inside of Reactor. And that's the cool thing about virtual triggers. So I want to show you how we can also do a selection of sources on an aux. So let's create another virtual trigger that does that. So that would be aux source. We do that, create. Okay, so we go in here. Now, actually, we need to select something very close to analog. This is something I added as I was preparing myself for this video. I found out that I needed to have a more smooth way to basically listen to the change of a value and then just have a binary trigger. And this is, yeah, that comes into play in just a short second, because what we'll do now is to still select an integer value that we pick. We can, in this case, take 61. So let's just pick 61, number 61 here. So we are listening to integer 61. When that changes, we want something to happen over here. But as I said, I just added this. So basically, I need to use JSON to edit this one. I think maybe it is actually updated. It says change here, but it's just not in the UI. So it is explained that it works. But I type in change and save. So now you can see the mode is not selectable up here because it's not in this dropdown. But it is actually set to change. So in any case, whenever... yeah, okay. So I have the IO reference down here. So whenever integer number 61 is changing its value, I'm going to receive a binary trigger into my behavior, which I'm going to create now. And that binary trigger would basically be like set value. And we set the value. Is that a good idea? I will just create one basically from scratch. I think I'll just make one with an event handler. Okay, so set source. We'll set source. So I have an event handler for setting the source. It should be a binary type because I have a binary trigger coming in. The value that I want to set would be the one from my TCP server device core. I'll pick integer number 61 here, click, select. So integer 61 is the value that I'm going to inject into the parameter, which I will select from the ATEM device core. So I'll just type in aux video source right here, and we need to pick the aux. I have only one, so it's aux source number 1 that I'm controlling this way. So actually it should work right now. We take the value of this integer, we use that to drive the source of the auxiliary, and that happens anytime I see a change to the integer 61 right here. Let's see if this is working. We have the currently camera number 2 here on the auxiliary. So if I type in integer number 61 equals 3, I should be able to see that change happen up here. It's now camera number 3. No, it's not camera number 3. It's a little bit annoying that we can't see it like that, so maybe it's more visual if we put it like this. So actually, let me just quickly check here and go back to this one and edit the parameter that we're changing. So instead of auxiliary, let me just use preview video input, this one on ME number 1. So this is the one that we'll be driving. We'll still be using integer 61 to drive it, and we will, okay. It should all be fine. Except I'm not super happy about what I see up there. Let me just quickly check here. I don't want to have a parent ID of audio meter. That's a little bit weird to me. So I just want to have a behavior without any such thing. Okay, what happened now? I think I removed a little bit. Oh, too much. Let's see, that's the danger of the JSON editor. Okay, format looks great. Save. It's all good now. All right, let's go back here. We should now see the preview row change as I am using integer 61. So let's just type in integer 61 equals 1, and we see preview change to camera number 1, integer 61 equals 2, changes over there. Now, of course, we don't have the other way because this is not like, we don't see what these sources are. I think color 1 and 2 might be like 2000. So we could try that out. 2001. Yeah. Oh, well done, Casper. Okay, and 2 is color number 2. Okay, so how do you know that? Well, you could actually, because now you're operating on the level of the ATEM protocol. So if you go to the ATEM device core, you open the parameter list, you will see a chart like this. And if you type preview video input source, preview input video source, there you see, and for each of the models, you can see what the values are, but the color generators would always be the same. So 2001 and 2002 would be listed in those cases. So final thing I wanted to do is to basically let the keyer here transition. This is another example where we would, let me see, now I get confused. Let's quickly go back in here and do the final and 4th virtual trigger of today. So, and this one would be keyer toggle. Keyer state, whatever. You can call it whatever you want. But what I want to do now is to listen. In this case, I also choose it's actually the change. Once again, I had these 2 cases where it would be very, very useful to listen to a change in a value. So I listen to a change of a boolean value, and we just, again, we pick whatever we like, 160, boolean value 160, and when that change, and this is the thing I need to do because I did not have a UI for it, okay, save, when that change, 160, boolean 160, when that change, we want a behavior to change a parameter in the ATEM switch. You will just find that, and it's a keyer cut. I don't like that it's called cut actually, because it sounds like a trigger. Oh, not downstream keyer cut, but upstream keyer cut. Upstream keyer cut right there, and that would be an ME1, upstream keyer number 1. So upstream keyer cut here, I want that to Actually, I want to do the same as I did before. And again, I don't have a great master behavior for it. So I'm going to create an event handler myself that will handle this event. I'll, set Kia state. Just call that. It doesn't matter what it's called. It's just a reference that you may or may not use if you get fancy. But I basically want to say the parameter I want to set by this would be this one. So the ATEM device calls upstream Kia cut in ME number 1, upstream Kia number 1. And it should be set to which value? Well, in this case, just to illustrate not to illustrate any point. I want to set it to the value of the TCP server, because the cool thing is that this value, the boolean, is also a binary value. So all I need to do actually is to just set it to the same as that one. In other words, if this is true, this is going to be set to true. If this changes to false, this is going to be set to false. So right now I have exactly that function, because it happens so that the boolean is a binary value, and the same is true for the upstream Kia cut, which, by the way, is something you could check if, again, you go into this list and you say upstream Kia cut. You can see it's a binary control value. True and false is going to work for this one. So we can just transfer the value directly between the two. So now we have these 4 virtual triggers, and the Kia is the final one we need to check. So I just need my terminal open here so I can show you that this works. Boolean number 160 equals 1. And you see it's now turned on. That's great, isn't it? And then I can go in here and then I can turn it off, and the Kia is off. So I have that. I have my source selection. I have the ability to control volume and audio by an integer, and also send a cut action to the ATEM switch. And that's all thanks to virtual triggers taking their inputs from the TCP server device core.